Okay, welcome. Our talk is how to get continuous delivery past your security officer. No mean feat for some people in some companies. My name's Mike. When I'm not laughing at internet videos of cats doing stupid things, I'm probably playing Minecraft with my kids, or being beaten up by my kids, or telling my kids to stop whatever it is that they're doing. When I'm not doing that, I'm probably playing with some little bits of electronics, or trying to work out what weird device I can install Linux on just for the fun of it.
Francois, Raynaud. I'm, can you hear me actually? Senior Manager Monitoring and Response at Betfair. Started as a pen tester, wore all different hats, the darker the better, and just started to think about actually it's time to provide my services to company and look on the other side of the fence. So that's where we are today.
Cool. So a little bit about Betfair. The company was born in 1999. We've got offices all over Europe. We've got an engineering blog run by Richard Hay. He's site reliability engineering, DevOps champion, all kinds of stuff. We've got probably more like 800 engineers, developers, 3 main products, and some stats. So the interesting one is we do 50 million transactions a day, so that's a bet. So the website's quite busy, and we turn those transactions around typically in less than 4 milliseconds. So quite a lot of tin in the data center. So this is what a typical security officer would definitely have said a few years ago. Probably most of them are still saying it. No, you can't do that. Whatever it is you want to do, the answer by default is no. We like a bit of a challenge, so when the idea of continuous delivery first came along, rather than say no, we said, well, what is that? How does it work? So about 5 years ago when I first joined Betfair, it was already an agile development shop. The release velocity was, for most projects, every other week, maybe once a month. And then Dave Farley, who's speaking after this session in the big room back there, I think, he worked at LMAX, which was originally owned by Betfair. He wrote the book on continuous delivery, and he sold the idea of continuous delivery to the architecture team at Betfair. And we kind of liked the idea, so we thought, yeah, we'll have some of that. So we started trying to build the capability. The security team back then, we reviewed everything before it went into production. We did automated pen testing, manual pen testing, code reviews, static code analysis tools, loads of stuff, and we did it all before we would sign off a release that it could go into production, which isn't terribly continuous delivery. So the development team started speeding up their release cycles. They were getting down to weekly releases, and then ultimately some front-end areas were doing daily releases, and we were still trying to do daily pen tests, daily reviews, and it was just becoming silly, incredibly resource intensive. So we decided, okay, we need to change. We need to come up with something better.
So why is a security officer not happy about it? That's a few of the examples we heard about it. I'm not going to go through them. To us, changing is good. We always like to challenge the status quo. That's what we're doing in security. You're looking for ensuring that everything is working. We're just trying to make sure how we can actually abuse them. Speed is really key in the society, especially for us, the numbers that we actually have to deal with on a daily basis. I remember working for certain space European agency, I'll just change the name here, where the security officer was still asking everybody in DevOps to fill in some detailed design by hand. So that resulted in my teams having to recruit lots of people able to actually recognize handwriting to be able to convert that automatically in our system. So what did we do? How did we do the pipeline? Overall, so you recognize the schedule of the pipeline, continuous delivery. The aim is for us to arrive as early as possible to be able to exchange the ideas and understand what you're doing, how we're doing it, how we can help each other. So we start with a goal build. So we're going to take this goal build, we're going to work with DevOps and say, what is the bare minimum that you actually need in order to make this system work? We test that, we thoroughly test it, we improve it, we harden it. Then we actually give it back to DevOps and say, here you go, that's the build that you're going to use to actually go through your pipeline. They play with it, they instantiate it, they put everything in it, and they say, but we're ready for QA now. They say, okay, not a problem. So at the same time, what we're going to do, the same build is going to go for the QA testing, but it's going to go into security testing at the same time. Two parts of it, and Mike will explain a bit more about it, the application risk calculator. Then we've got the Vanity Scan, which is telling us, if you're above a certain threshold, we just kill you. And you just go back to the beginning, you do all your patching, you redo all your configuration. And then you keep going, integration tests, and you got back in production. We've got all the appliances as well in production, so we can actually check, is this build exactly the same as what we certified from the beginning? Any changes? Are you actually respecting this immutable concept? And it works. So how do we do it? So kind of tooling, we're not sponsored by anybody, so we're not calling out name here. So static code analysis, but Actionetics, Fortify, some of them are commercial, some of them are just completely open source. It really depends on what you want. For the vulnerability scanning, we went with Qualys. So Qualys is enterprise grade system. So we've got cloud architecture, on-premise appliances, but we also got all virtual scanners. Obviously, speed of delivery, you can't have the old traditional model where one appliance is just going to take care of everything. You need to expand this. Again, this is just an example of how we're doing it. The right tools, it depends on you and how much money you've got, obviously. But we recognize there is problem with security tooling. They're not ready. They don't understand. For example, at the moment, we've got to deploy a new system, and I've got to deploy 50 virtual scanners at the same time. My security vendor is just telling me, but how are you going to do that? We can't manage it. Now, we need the licensing in place, we need to activate it. So they're not ready at all. So we've got to create our own bespoke tool, our own pipeline, in order to use the tool, abuse them. Traditionally, they charge you a lot for hardware appliances. A virtual scanner is completely free nearly. They haven't got the trick really already. So we're just shifting from the appliances to the hardware. Instead of paying hundreds of thousands, you go for virtual scanners, and it doesn't cost you anything. You're using the API, it's completely free. So that's the type of thing. Understand your product and abuse it.
Okay. So from an application perspective, this is kind of a complicated slide, so I'll try and avoid going off on a sidetrack. There's a bit of maths and a bit of gamification. So security is really a game. There are bad guys out there, and they want to abuse your system. And because they exist, we have good guys trying to defend and identify the problems and fix them. If the bad guys would only go home, then I could go back to watching cat videos on YouTube. And the maths of it all basically boils down to the time to find an issue and the time to fix it, so this is what the good guys are doing, needs to be smaller than the time to find an issue and the time to abuse it, which is what the bad guys are doing. And if we do that every single time, we will win. So we've defined that as the level of security we're aiming for. Works quite nicely, but it is a little bit fluffy, and these things vary quite a lot. So when it comes to developing code and putting it into production, in the old way of thinking, because the security team were involved ahead of time, they had some time to do pen testing, I'm going to call that risk avoidance. The code never made it into production, it was never exposed to bad guys, and so there was never any problem. But nobody's perfect, so some of the issues still were undetected and went into production. So this is just the issues they find. And they find them either through automated tools, which is great because we're going to put those in the pipeline. So we're not going to make that any worse. And they find them through manual pen testing, which we can't put in a pipeline. There's no automated tool that understands how to pen test business logic. Right? The concept doesn't exist. It needs a human being that understands the workflow involved in the application. So there's a gap there. And so that risk goes on kind of like the scales of we're not going to be able to address that. And then the risk reduction piece is a problem has made it into production. How quickly can we then find the problem and then fix the issue? Now, ironically, the big issue or the big differentiator isn't the time to find it, it's the time to fix it. in a traditional releasing once a month, or God forbid, once a quarter, you're exposed to that issue for quite a long time. And unless it's a P1 and you say, stop everything, right, fix this immediately, even if it's 3 o'clock in the morning, those issues exist in production for a while. So with continuous delivery, we can turn around and say, any security issues that come in, they will go straight to the top of the backlog and they will get fixed. And because it's continuous delivery, as long as it doesn't break the build or any of the tests, it will be in production 20 minutes, an hour later. And that brings the timeframes down massively. So then we get to a point where we can say, actually, the risk before was this big, and the risk afterwards is whatever size it happens to be. Now, it might still be bigger. You might be saying, I haven't managed to reduce as much risk. So then we have to look at some of the other benefits of CD. Things like Heartbleed, Freak, some of the OpenSSL attacks recently, they're not really anything to do with the app. The infrastructure needs to be patched. And if the infrastructure is going through the same pipeline, we get the same benefits in terms of time to fix. And that's great. Now, hopefully, the scale has swung, and by doing this, we're going to reduce the risk. Even if you haven't managed to do that, which I would hope you have, the other business benefits of continuous delivery, like time to get features in front of customers and provide value, hopefully they will outweigh the cost of that risk. And that's a winning argument, because that's the rationale that security people talk. It's all about risk. But if you have some residual risk that you haven't managed to close off, and everybody will, it's a good idea not to just ignore that. So we've developed something called an AppSec risk calculator. It needs some kind of code name, which is cool. It's not a very good name at the moment. And it essentially takes a bunch of attributes. So here we have around about 20 attributes about the project, about the change, and then a whole load of different answers. And so these are weighted. Each of the questions has a weight. Each of the answers has a weight. They're pushed into a mathematical model, which then munges out a risk score associated with this application change. Provided the score is lower than the warning threshold or the error threshold, it just goes straight through into production. The thresholds are defined by the product owner. The product owner owns the product. They are accountable for the risk and the security of their product. We work with them to help them understand the difference between 400 and 2,000, right? What's a sensible value? The risk calculator is also aware of something called inherent risk and avoidable risk. So if you're building a CRM solution and it has all of the customer data in it, that's a lot of sensitive data. By definition, you're not going to be able to say, I'll reduce my risk by not handling customer data. You can't. You need to handle that data. So that's a fact of life and not an avoidable risk. Whereas not having good, strong input checking is an avoidable risk, which you can then work on to deliver and bring the risk down. And then all of this is JSON in, JSON out. And ironically, the input and the output is the same format as well. So it means we can just rerun it to verify. And every time the calculator is run, it publishes the JSON blob to a server. So we have a bucket load of data for reporting, audit purposes, trending. So there's a whole load of dashboards on the back of this as well. This is just the HTML version so people can play with it. There's a Java version and weirdly an Excel version which helps you work on the mathematical model. And then that Java version just drops into any of the pipelines. So we've got a couple of different pipeline delivery technologies. And it literally just sits there in the pipeline. If everything is still low risk, lets it carry on. The attributes will vary from company to company, and you need buy-in to get these kind of things through. So we went out, we got some independent third-party security consultancy to come help us out. We got development teams involved. We got OWASP top 10, threat modeling, lots of research, like what are the common attacks and the vulnerabilities used within them. and just sort of threw it all in a big pot, stirred it up, came up with the attributes for us. There's probably about another 30 on top of the ones that I showed you. They weren't significant enough to warrant trying to automate getting the answer to these questions. So there's no point having questions if people just fill them out manually. So behind the scenes, each of those questions we try and answer automatically at build time. So we reduce the ones to the significant ones, and it uses basically a balanced scorecard is the mathematical model. And then finally, we kind of have to accept that continuous delivery isn't right for every component. So Betfair is a highly regulated business. We do gambling and gaming. So we have regulators all over the place. We're a floated PLC, so we have internal audit, external audit. We do card payments, so we have PCI. We have a lot of people interested in what we're doing, how we're doing it. And there's a couple of components which we haven't managed yet to be able to satisfy some of these external auditors. So that's fine. CD is involved from the code check-in all the way up to it's ready for production. It's just then that it stops for a manual phase. Have the product owners be accountable for security. Have the delivery managers be responsible for the security of the product. So that involves some awareness, some training, some understanding. Don't necessarily expect the security team to do everything for you. I wish we could, but there aren't enough of us. Change the definition of done. So I liked in the previous talk that there was like, what is the definition of done? And for some people, it's like, well, I committed the code. That's not good enough. I'd take it a step further, which is the code is in front of customers and adding value. So that's probably where a lot of people draw the line. And the security has been demonstrated to be okay. Now that might mean if you do quarterly pen testing, that user story is pretty much done, but isn't actually fully done until that pen test has been run. It just stops silly arguments about, was the user story right in the first place, or is this a defect? It's kind of like, we'll say the user story was never right, and a developer will say raise a defect. Start small is always a good idea, a common theme. If you have security concerns, think small risk rather than small complexity. So pick an internal tool, something that doesn't involve external access or sensitive data. Cool.
So we started as in how we're doing it. How did you convince us, basically, that it's going to be okay from a security point of view? So that's the kind of things that we'd be really pleased that you come to us and you say, that's okay, we can do CD, and we give you the ability to kill the build. So the trade-off is the one at the bottom where you say, okay, we give you an exception process at the same time. So as Mike was explaining, you've got shell shock, let's take 5,000, 10,000 servers. You've got to redeploy those 10,000 servers immediately. That's not always going to work out. So you've got the exemption process. And of course, that's in line with the risk, which is, well, how long can we accept this risk to be here, etc. Lots of metrics. Send us as many metrics as you like. We love metrics, and especially our CISO. CISO, they only look at this. We can have like an animated GIF, which is going to change from red to green. That will please them as well. But give it to us. That's what we need. That's what we're here for. But on the other side, we will always give you some feedback. So the advantage of plugging ourselves into the pipeline, continuously we can actually give you some feedback, as in, this is not working here, go back, let's do it. And we've got those loops at the moment where some people don't get out of it for, well, 25, 30 minutes, which is not a problem if you compare to like 3 to 6 months before, how you had to fight with all the development team, with all DevOps, sysadmin, as if you're going to patch it. Is it? No, we can't patch it. That's for X, Y, Z. Let's think about it, how we're going to do it again. And as Mike was saying, it's this available versus inherent risk. That's something we're just really keen, as in, we're here to help you. We're here to guide you on how to do it, but you've got to learn a bit about security. If you want to sit down at a pub with us and we can just explain to you everything, what is our passion about risk? Why does it work really well within continuous delivery? We're actually really keen on it, and I think by working together, the time to market is going to get much better. That's what our CISO said. And we're really pleased. So we've got full support in Betfair from having like a great security team, which is helping us on those new projects and taking part of this CD today. So that's where we are. Thank you very much. We're open for questions. Yes.
What happens if you don't get the product owners buy-in for security, if they just want to see features? Have you ever had that, I guess?
Yes, we have. It's not an uncommon problem. And so you have to meet with them, you have to talk to them. It's the same kind of questions about the product owners responsible for the quality of their product. Security is just another facet of the quality. And it really varies depending on the individual. Some people are a little bit nervous, but then when they realise there's going to be support, they're okay with it. Other people will fight you tooth and nail to say that isn't my problem. It just takes time.
In terms of reducing risk, particularly reducing the time to find after a release to production, things like easy to find, responsible disclosure, information and bug bounties and things, obviously are a really good way of reducing the risk if things do get into production. How does Betfair have good policies in that sort of area?
We don't currently have a bug bounty. We do occasionally talk about it. I personally think it's a very good idea. If somebody's going to find a problem with your website, I would much rather they tell me about it rather than sit on it for maybe 6 months and then tell somebody else who decides to use it for something. Yeah, so we do have customers who tell us about problems. That's good. They're not shy.
Anything else?
What sort of order of magnitude would you put on putting something like this in build pipelines? So you've currently got your vanilla build. How much? I suppose it's two splits. How much effort it took to put it in? How much did you find? How much did you find you could incorporate off the shelf sort of pen testing software and this sort of thing, as opposed to looking how to build yourselves?
Do you want to take that one?
Yeah, there's two parts here. This took from conception to delivery 3 months. And as I said, a combination of open source, combination of really clever people that we employ to actually build it. But that was the easy part, I have to admit. The hard part was to convince security partners that this is where they should be going. And it's an ongoing project. From the application risk calculator, it took a bit longer.
Yeah, so the risk calculator has been around probably for about 9 months. We've got it in 90% plus of our pipelines, and we've got something like 200 pipelines. I think the biggest problem is that you can't just go out and buy a tool. I wish we could. Right? We've got the money, we could go out and throw money at the problem and solve it that way, but the tools just don't exist. So we've had to build a lot of these capabilities from scratch.
Yeah.
What type of vulnerabilities have you found in the pipeline? Like what has made the build go red?
So most common ones could be people are behind in patching. So they're still trying to deploy something on Solaris 2.2. It's like, no, that's not going to work, really. It's not going to fly, guys. And it's all about us understanding the type of vulnerability that we want to protect against. So you've got to understand, is it going to be externally facing? What kind of services this is going to provide? But that's the advantage of the first part, which is the gold build. It's just remove what you don't need. You don't need to have Telnet here. Just put SSH. And it's changing the mentality of it. It's, yes, you need a password, that happens. Sorry about that. It's a bit of a pain. We will admit it. But there is a reason for that. Other type of vulnerability, cross-site scripting, data exfiltration. There's quite a few bits within the application risk calculator. But it's, so if you take tools like, not to name it, Qualys or anything, they will have 20 to 40,000 checks. And you're going to end up with about 20 to 40 type of vulnerability that you're going to find on the system. Obviously, having something off the shelf, you're going to only get off the shelf and publish stuff. So that's why we need much further testing. We've got some third-party companies, we're hiring some pen testers to help us understand. It's just let's take some time with it. Let's take apart the application, look at it and see what we can find. Let's reverse it and just throw as many people at it until we find everything.
I mean, we have a bunch of code quality checks. Ironically, by going out to development and explaining to them, you need to be aware of security, the common mistakes, and how to validate your inputs, format things properly. We just don't see so much of that anymore. So we used to see build after build being killed because there was a potential SQL injection. The developers have learned if I structure my code this way, I end up with a false positive. So they just don't structure the code that way anymore. They've learned that the tools will stop the build, so they've changed the way they structure things.
And the key point, sorry, I'll take this one. The key point is really having those touch points all along the pipeline as quickly as possible, so you can fix it really quickly.
So I was going to ask about the false positives and stuff as well. So one of the problems I've seen with static analysis tools for security in the past is that there's either no way of creating specific exceptions, as in, I agree with the rule, but this isn't the rule, or if there is a way, then it fails when you refactor. So, for example, a server somewhere stores a line number and a class name and says you've ignored this particular exception. What's it like with the tools that you use?
It's not good. They're not designed to be aware of this kind of approach. So if you have a list of 20 builds, and so Jenkins goes to the most recent build and kicks off a pipeline for that. If it goes red, it moves on to the next one until it finds a build that is going to pass. So that's not in the order the code was written, if you follow me. So tools like Fortify, they see a code change, and then it jumps forwards, and then it jumps backwards. And it really confuses the tool.
Visibly wins when you said Fortify.
Yeah.
Do the tools that you use, are devs able to run them as part of the local build as well?
Yes. So we don't want to own those tools. We don't even want to run them or see the reports. We just have a requirement that there are no high severity issues. And so the only thing we check is if a developer suppresses an issue saying this is a false positive, we review it to make sure it actually is.
And so a final question on that, the speed of so not for the static analysis, but the scans, what do you find the speed's like for the automated?
Between 8 and 12 minutes.
Okay.
Yeah.
Is it a kind of a web application component?
No, that's the whole server, the whole stack, OS to everything deployed. So that's the advantage of it running in parallel with QA. So QA is going to take between 12 and 15 minutes. We can do exactly the same time. It can be in parallel because the feedback loop will need to go back anyway. So it's, yeah.
Does that include things like fuzzing tests and stuff, which would typically end up taking much longer, or is it quite narrowly?
No, so we don't tend to do fuzz testing. So we have got security unit tests where we say, I don't know if you remember a while back, Dropbox had a vulnerability where the password was kind of irrelevant. So we have security unit tests where we say, okay, you need to be able to log in with username and password, but it does need to be the right username and password. So we test, we know this is wrong, and if it doesn't fail, then that's a failed test.
So do you have any pipelines or any automation on your network configuration?
That's the future. So what you can do, actually, you can incorporate that with NSX, SDN, and you can have things completely reconfigured automatically. You can use it for incident management as well. You've got something infected, reconfigure the network, put them in a quarantine network. That's leave us 6 months, or Betfair time 2.5 weeks, and we need to deliver it. It would be ideal. Ultimately, what you want to do using SDN, so it's going to be, I want to deploy something, and I put it in one of my tiers. Depending on which tier you're going to be into, the security can be changed accordingly, externally facing, more secure, further inside the onion, you're relatively fine. But to complement this, you need the monitoring to be in place. So again, as Matt was saying, it's just like, what is the status now? What is my baseline? What is my application doing? Does it change over time? What is the logic between my externally facing, my business logic, and my backend? It's all about including monitoring, the automation, and understanding what your applications are doing. And I think that's the whole problem that we're all experiencing, which is there's not enough communication between dev and security for us to understand what you're building, what are we trying to protect. So let's all sit down around the table. That's the point. That's why we're here today. We didn't get shot, which we're actually quite surprised. But we're here to help. You've got the tools. I haven't run any quality scans. It's basically all DevOps. They've got access to the API. They're doing themselves.
I mean, just on that, we do use APIs to talk to load balancers to bring in new VMs, wait for them to be sanity tested, and then take out old VMs and kill them. But things like connectivity between components, we don't automate calls to a firewall to say, okay, add a new firewall rule. So hopefully software-defined networking, where you just tag it as a box of type X, and magic happens. So we're looking into that right now, and it's looking quite promising, but we'll have to see how it works.
Just a question, how did you get the...
No, I see we have to stop, sorry. We'll have to be at the pub.
I think it's a break now,
It's a
so
half
feel
hour
free
break,
to...
so, yeah, you can continue the conversation. But...
Cool.
Sorry.
Thank you.